This is part 2 of our discussion on slope of a line. Please get out a piece of paper and follow along, and then bring the paper to our next class. We have calculated the slope of horizontal and vertical lines, and we've read the slope of horizontal and vertical lines, so this should be a review. Take a look at this graph. Here you see this horizontal line, and below I have sitting here an IO table for you. I would like you to draw an IO table on your paper, and the 4 points that you see on the graph, I would like you to enter into this IO table. List the X and Y coordinates for each of the 4 coordinates. Stop the video and fill in the table and give the X and Y coordinates for each of the points above. Hopefully this is what you have in your table. Now let's actually calculate the slope of this horizontal line by picking any of the 2 points. So why don't we take the first point and this third point. So in order to calculate the slope, we're going to stack our 2 points like we've been doing in class and make a subtraction problem. Delta y is equal to 4 minus 4 over delta x is equal to 3 minus 0. I want you to follow along and write this on your paper. So now complete the problem. Change in y, 4 minus 4 is 0 over change in x, 3 minus 0 is 3. And the fraction 0 over 3 resolves to 0. Now let's go back and actually read the line. If you read the line from left to right and you put your pencil on the first point, you will be sitting right here. The change in y, or the rise, is 0 over change in x. Well, you can go from left to right and have 1 unit, or you can continue on further and go from your first point to your third point and have 3. And you'll also see that 0 divided by 3, or if you did 0 divided by 1, in both cases you will end up with a slope of 0. So what is the slope of a horizontal line? As we've been saying in class, the slope of a horizontal line, it's a 0 slope. Now let's do the same with the vertical line that you see. Here's the IO table. I want you to write in the IO table the coordinates for the 4 points that are graphed on the vertical line. So take a minute, draw the IO table on your paper, and give the coordinates. Your table should look like the table that you see. So now let's calculate the slope of that vertical line. To calculate the slope, we can pick any 2 points on the line. So I'll randomly pick this second point and the 4th point. So to calculate the slope, we stack them. I want you to follow along now and do this on your paper. We make it a subtraction problem because subtraction means change in, and change in y, remember x, y, 3 minus 5 over change in x is equal to 2 minus 2. So now let's resolve the problem. 3 minus 5 is negative 2 over 2 minus 2 is 0. That is not our slope. The final answer for this slope is undefined or no slope because you cannot have a 0 in the denominator for a fraction. So when you get 0 in the denominator, you end up with an undefined or no slope. Now let's go up and read this line. We read the line from left to right, and in the case of the vertical line, find a point on the line and whether your change in y is a rise or a fall or a drop, it doesn't matter. So your change in y, I will start at the top point up here, and I will go down to the bottom point. My change in y then is a drop, which is negative. I'm at positive 5, down to 2, negative 3. So I drop down to 2, down 3, but there is no change in x over 0. So change in y over change in x on a vertical line, as I read it, I get a similar type of answer with 0 in the denominator. So again, this is an undefined or no slope. So, what is the slope of a vertical line? Vertical lines have no slope, and you need to keep straight the difference between vertical lines with no slope or horizontal lines that have 0 slope. So now we need to discuss slope as a rate of change. In other words, we need to talk about slope in the real world. And in the real world, slope is a rate. So here we go, let's read this problem. In 1994, a video store had 23,500 rentals. In the year 2000, the store had 28,540 rentals. Find the average rate of change of the store's rentals in rentals per year. So that's a key phrase right there, rentals per year. So let's write that rate, rentals per year, as a fraction. Rentals per year. So by writing this rate as a fraction, and now that you understand the definition of slope, change in y over change in x, you clearly have in front of you what the y variable is and what the x variable is. Based on the definition of slope, the rentals in this problem will be our y-coordinates, and the years in this problem will be our x-coordinates. And again, it's because of the definition of slope. Rentals per year. Write that rate as a fraction, rentals per year. That rate is your slope, and by definition, slope is change in y over change in x. Notice how I wrote it right next to my English rate. So I'm going to go back in my problem now, and I'm going to label my data. In 1994, the video store had 23,500 rentals. That's a relationship. So 1994 is x, again, based on my rate and definition of slope. The store had 23,500 rentals. That's my y-coordinate. So I have an ordered pair. 1994, comma, 23,500. Now you need to write this on your paper. Stop the video, write that ordered pair on your paper. We have another piece of data. In the year 2000, the store had 28,540 rentals. I'm going to label the x and y coordinates in that piece of data. Again, the year is x. These rentals are y. So now I'm going to build an ordered pair with that data. The year 2000, the store had 28,540 rentals. So again, by definition of slope and my rate of rentals per year, I was able to build my ordered pairs x, comma, y by pulling the data from my problem. I want you to write this other ordered pair on your paper just like I have. If you do not understand how I arrived at these ordered pairs, stop the video, rewind, and listen to it again. So now I have the ordered pairs for my data, and I proceed and calculate this rate or slope like I've been doing. So here we go. I'm going to make a subtraction problem. Okay, I'm going to move my problem over and use my whole screen here. So change in y is equal to 23,500 minus 28,540 over change in x is equal to the years, 1994 minus 2000. Okay, so let's go and finish it off. 23,500 minus 28,540 is a negative 5,040 over 1994 minus 2,000, that's negative 6. So when I resolve this fraction, negative divided by negative, it's positive 5,040. I would like you to go off on the side of your paper and do that division. Stop the video. Go do that division by hand. You will get an even integer. You should have gotten 840. Now we need to put a label on this. This is a real world problem. Rentals per year. If you did not understand this word problem, you need to rewind it and listen to it again. It all starts by writing this rate of rentals per year, right here, as a fraction. And then putting the definition, delta y over delta x, next to it. That way you know exactly that x is year and the y is rentals. Then you go back into your problem and build your ordered pairs. Okay, let's look at one more real-world example. Follow along on your paper and write this down as we go. Now we're going to read a graph. The graph shows the number of people, in millions, by the way, who visited the U.S. theme parks in recent years. Our job is to find the rates of change for the years 2000 to 2002 and 2002 through 2004. So first of all, let's study this graph. Notice the horizontal axis right here, which in our mind is x. They're the years. And then the vertical axis is the attendance in millions. So let's find the rates of change from 2000 to 2002. So we're interested in this from here to here. So we need to identify the ordered pair or the coordinates of this first point. So the x value is 2002. The y value, you're told it exactly, 324. And by the way, don't forget that's millions. The other value we need is for the year 2000, and that is 317 million. So, write this ordered pair down on your paper. I would like for you now to calculate that rate of change. Okay, take a look at what I have on my screen in red, and I hope that's what you have on your paper. Change in y, remember, x, y, 324 minus 317 equals 7. delta x, or change in x, is equal to 2002 minus 2000, and that is equal to 2. So 7 over 2. Now, in real life, we need to interpret that. We're talking about the change in attendance per year. So we are not going to leave that as 7/2. We need to interpret that for the real world. That really is 3.5 million people per year. Make sure you remember to use millions because it's 3.5 million. It's not just 3.5 people per year, big difference. And make sure you label your rate. Okay, now let's calculate the rate of change in attendance from 2002 to 2004. So now notice 2004, the data point right here. So the ordered pair for 2004 would be 2004, comma, you're told exactly 325. Write this on your paper. The data for 2002, that ordered pair, 2002, 324 million. So go ahead and calculate the rate. You do it by yourself. Okay, I hope you got what I got in blue. Check your work with my blue work. So the change in Y for the rate for the years 2002 through 2004, 325 million minus 324 million is equal to 1. Change in X, 2004 minus 2002 equal to 2. So the rate of change in attendance from the years 2002 through 2004 is 500,000 people per year. Make sure you included the million and the label people per year. Okay, finally, we need to calculate the rate of change from 2000 to 2006. So let me just get this back here. There it is. Okay, so now on your paper, I want you to do number 3. Whoa, let me fix this up. I want you to do number 3 completely on your own. So you need to calculate the rate of change from 2000 to 2006. Find the ordered pairs on the graph. Write the ordered pairs on your paper. And then calculate the rate of change. And don't forget the label. Stop the video, go do it, and then come back and check. Okay, once you've completed your calculation, take a look at my green work here on the screen, and you can see that I have found the 2 ordered pairs from 2006 and 2000. And I've listed the 2 ordered pairs, 2006, 335, 2000, 317, and I've done the calculation delta y over delta x. And remember, those are the x, these are the y's. You should have gotten 18 over 6 equal to a positive 3 million people per year. So when we interpret this picture, on average, the rate of change in attendance from the year 2000 to 2006 is on average 3 million people per year, an increase of 3 million people per year. But if you look at the graph, let me stop for a second, and I want to clean this up. But if you look at the graph, there are certain time periods, for instance here or here, where the increase was more than the other. In particular, look at from 2004 to 2006. The line increases sharper, it's steeper, the increase is greater. So who knows what could have happened. Maybe the economy is a little better between those 2 years, and more people are going to amusement parks. Between 2002 and 2004, look at here, not as big an increase. This is when we had 500,000 people only increase, rate of change of increase, so it's not that much at all. So why would that be less? Perhaps a recession, not as many people traveling to amusement parks during that time period. Okay, you're going to do problem number 3 on your own. So continue on the piece of paper that you've been working with. Refer to the graph at the right. Here's a graph that shows the ticket prices for the Houston Astros from the years 1995 through 1998. Now, notice year 0 is 1995 because your first scale marker is for 1996. So your job, find the rate of change of prices from 2006 to 2008. Explain the meaning of the rate of change. Okay, so I want you to do that, and then look at B, without calculating. In other words, just look at the graph. Find a 2-year period that had a greater rate of change than the 2006 through 2008 change. Give an explanation why you think it's greater. And then look at C. Between which years would you guess that the new stadium was built? And explain your reasoning. So go ahead, do problem number 3. Bring it into class, and we'll talk about it in class.